Yeah, hello everyone. So, uh, okay, all set. Yeah, thanks for being here today. It will be my second time uh, discussing XCM NFT at the sub0 conference, but don't worry, I won't repeat myself. It's a new presentation. Uh, Today I will review the Unique Networks Treasury proposal about XCM NFT. I will talk about the concrete steps we're going to take to deliver the tools and auxiliary materials to bring the XCM NFT to life. Actually, it is already live since we implemented the proof of concept of XCM NFT and successfully made the first cross-chain NFT transfers between Quartz and Karura networks. It was the first milestone of our work. The following milestones are all about the things that will benefit the whole ecosystem and go far beyond the proof of concept. So let's review the milestones in general before we dig into the details. So milestone 2. The main thing we will deliver is the XNFT palette that implements the NFT XCM asset transactor and several other things. Also, we authored RFC number 37 about custom asset claimers. It is already accepted, so now we want to implement it. I will elaborate on why it is important for XCM NFT a bit later. Also, we're developing the XCM runtime API. It should benefit the UI and wallet builders since it will help them estimate the correct fees for XCM programs and also know the acceptable currencies in which the XCM execution fees could be paid. Also, we will implement a JavaScript API for all the previous things to make the lives of wallet developers and other front-end guys easier. It is not necessary to build a new library. We could augment an existing one. For instance, the asset transfer API developed by Parity. Also, during these milestones, we have already started the initial R&D process of adapting the XCM NFT to EVM. And finally, there will be documentation and educational materials for all the things discussed. So that's milestone 2. Let's quickly review the rest of the milestones. So milestone 3 contains the implementation of the EVM part and the R&D for the ink part. And finally, milestone 4 is about the XCM asset metadata RFC. As you can see, most of the work is in milestone 2. Milestone 3 is about the adaptation of milestone 2 to smart contract platforms. And milestone 4 sets the stage for XCM metadata operations. I won't go into the metadata things today. I talked about it at the previous sub0 conference. Also, we have already submitted the preliminary version of this RFC. If you're interested in this topic, check out the links. The left leads to the preliminary RFC, which is a more technical and concrete description of our vision of the XCM asset metadata. The right one leads to the previous sub0 presentation, a more general explanation with several use case examples. Okay, let's focus on milestone 2. What do these steps mean and why are they what they are? Well, they follow our ultimate goal of bringing the XCM NFT tooling to all the ecosystem members, and not just any tooling, but the one that the one is easy to integrate and use. To build such a tooling, the first thing we ought to do is to acknowledge the diversity of NFT solutions in the Polkadot ecosystem. Parachains are different, and they use different NFT engines. Look at this non-exhaustive list. We have unique network solution, open runtime module library NFT palette, 2 different solutions by Parity, solution by the Aventus team, NFTs and smart contract platforms, and so on. Also, NFTs represent not only the media object, but functional things as well, like the core time regions. So we expect new NFT solutions to appear in the future. A good XCM NFT tooling must provide all the necessary generic functionality that any of these NFT engines can use to send and receive both local NFTs and foreign NFTs minted on other chains. However, at the same time, to ensure the generality of the tooling, it shouldn't do too much. It must reuse the existing NFT solution of a chain as much as possible to reduce the integration costs, simplifying the review and audit processes. So let's look at the common traits of all the NFT engines. So any NFT engine, in one way or another, can create collections or something that resembles a collection. They can mint NFTs, transfer NFTs, and maybe an NFT engine can burn NFTs. Not all engines can do that. For instance, EVM-based NFTs may lack the burning operation. And of course, any NFT engine has storage for collections and tokens. On the other hand, we have XCM with transfer-related instructions. The transfer-related instructions are backed by the XCM asset transactor. Yeah, actually, by the way, we are considering only the reserve-based module because it requires fewer assumptions about communicating chains. Also, using this module, we can separate NFT metadata operation from transferring. I elaborated on this in the previous presentation, so again, if you're interested, please check it out. So, the transfer-related instructions are backed by the XCM asset transactor. The asset transactor is an entity the chain must provide so the XCM executor can use it to execute the transfer-related instructions. Without it, the XCM executor doesn't know how to transfer something on this particular chain. So for NFTs minted on this particular chain, the asset transactor needs just the transfer operation of an NFT engine. Why is that? Because if we use the reserve-based module, an NFT always stays on its original chain. And even if it is transferred to another chain, it only gets transferred physically within the original chain. During the XCM transfer, the NFT gets transferred to another chain's sovereign account. Of course, another chain gets notified about this, and it should mint a derivative NFT corresponding to the original, but that stuff is happening on the other chain. If we focus on the original chain, we really need only the transfer operation and nothing else. But it is enough only if we're good with transferring NFTs minted only on our chain. What if we also want to receive foreign NFTs? Or more precisely, if we want to have NFT derivatives on our chain? In that case, we also need to use the minting operation. Minting is required to deposit NFT derivatives within the derivative collections. Also, we can use the burn operation to withdraw an NFT derivative, but only if the NFT engine provides such an operation. But to start working with NFT derivatives, we must first have derivative NFT collections. So we need a mechanism to register the foreign collections on the chain. We can reuse the existing capability of the NFT engine to create collections. Some system accounts should own these collections. So foreign collections might be technically equivalent to regular collections, but the chain itself should manage them. A derivative collection corresponds to the foreign NFT collection via a mapping. Also, note that we need a mapping not only for collections, but also for individual NFTs. The NFT derivatives must correspond to the original NFTs. So the XNFT palette we are developing provides all the parts colored in pink. The XNFT palette follows our goals of making the integration simple and straightforward. It reuses the existing NFT engine logic for both local and foreign NFTs. And the last part is important since you are achieving both pieces of XCM NFT at once. And lastly, the XNFT palette provides the logic that should be implemented anyway if you want XCM NFT. The difference between the XNFT palette and the existing adapters from Polkadot SDK is in providing the logic for foreign NFTs out of the box. The XNFT palette requires the bare minimum from the NFT engine, which is enough to implement XCM operations. It doesn't require things that are not used in XCM. Also, the palette doesn't make any non-standard assumptions about NFTs. For instance, it does not think you can burn and then recreate the same NFT as the existing adapters do. Parity NFT solutions can burn and mint NFTs without losing their data, but that's not universally true. Open Runtime Module Library NFT palette, Unique Network, and many smart contract-based NFT solutions burn an NFT completely, including its data. Of course, the existing NFT solutions could be altered to support the existing adapters, which certainly increases the already steep integration cost. Or we could transfer an NFT somewhere when the adapter actually asks us to burn it. However, this also increases the integration and review difficulty, since the parachain developers must dig into the specifics of the adapter in order to use it. But most importantly, the existing adapters won't help you to deal with NFT derivative stuff, such as foreign collection registration, holding the correct mapping, and so on. The XNFT palette delivers all of the functionality in one piece, and the chain's developers will not have to know its low-level specifics. The palette will be well documented, all assumptions will be clearly stated, and it has a straightforward interface that separates concerns. Actually, I think we will publish a separate video about this palette explaining how to use it. You can check out the palette source code. Note, however, that it is still work in progress, but it is already beginning to take shape. Okay. Despite being the main thing, more than XNFT palette is needed to make cross-chain transfers convenient and robust. And to explain why, let us examine the relationship between NFTs and the XCM asset trap. Imagine we have two parachains, the sender chain and the receiver chain. Let the sender account initiate the cross-chain transfer of an NFT representing a sort. The sender account transfers to the beneficiary account on the receiver chain. But to complete the transfer, we must transfer fungibles alongside the NFT to pay for the XCM execution fees on the receiver chain. And not just any fungibles. The receiver chain must recognize them as acceptable currency for paying execution fees. And of course, there should be enough of them for transfer to go through. What will happen if one of these conditions fails? Well, of course, the assets won't be deposited to the beneficiary account. Instead, they will end up in the asset trap. Luckily, the trapped assets can be claimed, but only the sender chain itself can claim the trapped assets. This makes it difficult to claim the assets because you need either to appeal to the sender chain's governance or to use some custom claiming mechanism provided by the sender chain if one even exists. So appealing to the chain's governance is not a convenient way to solve a minor issue like trapped assets. Also, it is not easy for a chain team to develop a custom claiming mechanism, especially if more than two chains are involved. To solve this issue, we authored an RFC that proposes a new XCM instruction called setAssetClaimer. So the user can specify who can claim the assets if they are trapped. You can scan the QR code on the slide. You'll see the text of this RFC. Note that this RFC is accepted, meaning it will be implemented inevitably, and we want to be the ones who implement it. You might ask why this problem didn't appear with fungibles. Many cross-chain transfers of fungibles happen in the ecosystem. Is it really a problem? Well, most of the time, we cross-transfer a single currency and pay the execution fees using it. If you transfer a lot of fungibles, it will likely cover the fees. But when you transfer multiple currencies, which one should you use to pay fees? And remember, not all currencies are acceptable. And the execution price differs for different currencies. So the problem isn't apparent since we rarely transfer multiple currencies. However, transferring NFTs alongside fungibles is just a special case of transferring several currencies, where this problem will become evident. Even now, when we use XCM transfer in such a way that the probability of trapping the assets is low, we can see that some of them are trapped. For instance, you can query the state of the relay chain to see the list of trapped assets. Just query the asset trap storage of the XCM palette. Okay, when this new instruction is implemented, we can claim the trapped assets conveniently, but do we have tools to avoid asset trapping? Or at least make the probability of such an event as low as possible? Unfortunately, at the moment, we need to guess which currencies are acceptable on a particular chain. Also, you must guess how much you must pay in a specific currency. So now, we need some meta knowledge to be sure that our XCM programs will work as expected. To make the XCM programs more robust, we're proposing the XCM Payment API. You can scan the QR code to check out our pull request. It consists of 3 methods. The one for querying the list of acceptable currencies for paying the XCM execution fees on this chain. The one for weighing the XCM program, which you know will be executed. And lastly, the method to convert the weight into the fee in the selected currency. This API should be easy to integrate into any parachain, into any chain actually. We wrote an example integration for Rococo and Westend. The pull request shows how it works. I must mention that this API in its current state doesn't consider the delivery fees. Most likely, in the first version of this API, we will just add a separate method for delivery fees. Hopefully, with Parity and other people interested in this, we will find the proper solution for delivery fees as well. Also, a note about the last method. It returns a numeric type. This type is used to represent fungibles in XCM. In theory, we could pay for the XCM execution using an NFT. And in the light of core time NFTs, using some kind of execution ticket instead of a fee is a real possibility. However, currently there are no use cases for that, and we cannot tell how this will work in the future. That is why we only provide a method for converting the weight into a fungible currency. Luckily, runtime APIs can have several versions, and when it becomes more apparent how NFT payment for XCM execution will work, we can modify the API accordingly. Okay, having all of the described things, we will be able to implement the JavaScript API for UI and wallet builders, so they can provide a convenient XCM experience where users can choose the acceptable currency, estimate fees in the selected currency, and build robust XCM programs using the chain's interface. What is a robust XCM program? The one that has the set asset claimer instruction and the buy execution instruction with the fees parameters set according to the XCM payment API estimation. As I stated in the beginning, we could augment an existing JavaScript library working with XCM instead of writing a new one, but it remains to be decided. After having the core functionality in place and the JavaScript tooling for building frontend for it, we will adapt the XCM NFT to smart contract platforms. We have already started the initial R&D for EVM. During the next milestone, we will delegate the development of the EVM part to an EVM expert team and work together to deliver the best solution for this part. We will also conduct the Inc. R&D during the milestone 3. And finally, after having all the functionality for XCM NFT, reserve-based transfers on Substrate and EVM, having the JavaScript API for it, tests, documentation, and educational materials, we will conclude this effort by finalizing the XCM asset metadata RFC. This RFC sets the stage for future cross-chain metadata operations. So that's it. I'm looking forward to seeing our ecosystem where NFTs are easily transferable between chains, and these NFTs participate in various activities using the plethora of functionality of the Polkadot ecosystem. You can find links related to the proposal by scanning this QR. Of course, it also includes the link to the original proposal document as well. So yeah, that's it. Thank you.
All right, guys, we have time for a few questions. Anyone have a question here? Want to ask him anything? All right. Say, that's cool. Daniel, thank you so much. Thank you so much.